There we go. Everyone see that all right?
Yeah, looking good. Oh, everyone's muted, so you're not going to...
No. Watching for people like waving their hands frantically or something. Yeah, cool. Right, excellent. Cool. So, yes, thank you all for coming. We're going to talk a bit about Blazor this evening and why it's so exciting. This is a big passion of mine. So hopefully I'm going to leave you energized about Blazor by the time I've finished. I'm just going to quickly introduce myself. So my name's Chris and I'm a lead software engineer. I'm also a Microsoft MVP. I do a lot of blogging, a lot of writing about Blazor. I've been blogging about it since before the first experiment release came out. And then ever since, so I've got about 50 odd blog posts I think I've done on my blog about Blazor. I've written for Visual Studio Magazine and I wrote for Progress Telerik on their blog about it. And I also have done some stuff for Stack Overflow more recently. So that's fun. That keeps me fairly busy. And then I also do a load of open source work. So I have an organization called Blazor, and we do a load of controls to help you build Blazor apps a bit better and a bit easier. So we've got UI controls like type aheads and modals and stuff like that. And we've also got some helper libraries, so things that let you use things like the browser local storage APIs from C# really easily and efficiently and stuff like that. So hopefully there's useful stuff for you. So if you are doing any Blazor work, please check them out. So if they're any good for you. But that's enough about me. So I've got loads and loads to talk about. So we're just going to dive in and get going. So we're going to start with some fundamentals and work our way up to some more complex bits. So we'll start off with the fundamentals. So what is Blazor? Well, Blazor is a framework for building single page applications, or at least that's its initial intent. Blazor is, its concept is to be a direct competitor to Angular and Vue and React, but for the .NET stack, okay? And it's the brainchild of a guy called Steve Sarneson. Now, if anybody doesn't know who Steve is a member of the ASP.NET Core team, and he's got a rather impressive pedigree in this area. He's responsible for Knockout.js and several other amazing other little inventions that he's come up with. He actually presented Blazor as a part of a talk he did at NDC Oslo in 2017. The talk's on YouTube. I'd definitely watch it if you haven't, because Blazor isn't the main thing. It's like one of 4 things he showed in the talk. And by all accounts, I think it was number 2 or 3, and Damien Edwards and David Fowler in the audience, and kind of their jaws hit the floor when Steve did his demo of Blazor, and they kind of dragged him off the stage at the end, I think, to sort of talk to him about it. So it's quite a cool one to watch. In terms of sort of how we write Blazor stuff, we tend mainly use Razor. If you don't know what Razor is a language that's a kind of mix of HTML and C#. And obviously you can use CSS in there as well. Applications are built using components, which is fairly common for front-end SPA frameworks nowadays. All of the modern ones do this: Angular, React, Vue, pick whichever one you want. They're all using a component-based approach to building UIs. Again, similar to other single-page application frameworks, Blazor has a virtual DOM, which is called a render tree. They all have kind of different representations of this. The reason you have a virtual DOM is because doing operations against a real DOM is really expensive and not particularly fast. And the goal for single-page applications is to kind of make the minimum amount of changes you need to the physical real DOM. So they do all these change sort of churn against the virtual DOM, try and work out the minimum amount of changes they need to apply to get things where they need to be, and then they just apply that minimum set to the real DOM. So, like I say, render tree is the Blazor version. We'll kind of touch on this a little bit later on. And finally, and probably quite importantly, it works in all major browsers, including mobile ones. So getting something to work in Safari is sometimes a bit tricky, but Blazor does. In fact, in terms of compatibility, you kind of need to go back to something like IE 11 before it won't work. And even then, it's not technically Blazor that's wrong. It's the sort of the style of the JavaScript it's written in. So you can add some shims in, and I've seen people run Blazor on I believe it was an IE8 browser. I mean, it was just someone did it for a laugh, and it wasn't quick, but it did work. So, it just proves that anything's possible. In terms of what we're going to get with Blazor, well, this is the kind of stuff that we're getting out of the box. So forms and validation, pretty important for a single page application framework. We couldn't do a lot if we can't take some input from the user and validate that input and stuff like that. So we've got built-in components for doing forms, for input types, all that kind of stuff, and for validation. A lot of this stuff hooks into the existing stuff in the ASP.NET ecosystem. So things like data annotations just work with Blazor. So if you know how to do that from MVC or Razor Pages, then you're going to feel right at home with doing that kind of stuff. Code sharing, it's probably one of the big selling points for Blazor, especially if you're doing back-end work in C#. So if you're running C# web APIs, things like that, then Blazor is going to be a really good option for you, because instead of having to translate those sort of DTOs or view models or whatever from your C# representation to something like a TypeScript version or some other JSON version or something like that, you can just use the same C# classes. You can put them in a .NET Standard class library, and you can just literally project reference them between your front end and your back end. And that's it. Same classes, so you can just change them in that one place and use them in both. I think this is fantastic. I personally have been writing Angular front ends for a number of years, and I've lost count of how many times we've had little silly problems where someone's not added a property to a TypeScript model, or has forgot to remove one, and then you get a weird error that doesn't quite make sense, and then you do debugging, and then you finally realize, oh, we forgot to add that. Doesn't take long, but it is a pain, and that goes away with Blazor, so that's quite cool. As you probably imagine, being a Microsoft product, security is fairly high up on the list of things, and you kind of have full integration with Blazor. So you've got integration with Azure, so Azure AD, Azure AD B2C. In fact, any OIDC compliant identity provider will work with Blazor. Windows Auth, everything you kind of expect really if you're building a .NET app security-wise, you can do from Blazor. Pre-rendering, so this is important for SEO-sensitive applications. If you want to sort of have good SEO, you kind of need pages to have the right content on them, something that historically single-page applications kind of suffered with, because the content was always added sort of after the initial load, which didn't help sort of with things like Google bots and stuff like that. So the answer to that is server-side pre-rendering. Blazor has this in its server model. Pre-rendering is turned on by default. And for Blazor WebAssembly, the client-side model, you can do it as well. You kind of have to do a little bit of extra configuration to get it, but you can have that work. And I've got a blog post on how to do that, actually. Dependency injection, so that's baked in as you'd expect, again, with any sort of .NET app, .NET Core app. Dependency injection is a main feature. So that's baked in, same container that we get with the rest of .NET Core. So if you've done any .NET Core work, you're going to understand that pretty easily. Component libraries, so we can share Blazor components using Razor class libraries. So we can share them around between different apps in our organizations, or we can package them up and stick them on NuGet and share them that way. Really easy, really quick, really simple. The .NET ecosystem, this is kind of a cool one, because most new front-end frameworks have got to wait for some kind of ecosystem to sort of construct itself around them. And some frameworks live or die on whether that ecosystem actually happens. With Blazor, we don't have to wait for that. Blazor is .NET Standard compatible, which means if there are NuGet packages on NuGet that target .NET Standard, they're probably going to work with Blazor. Now, I say probably because there are some caveats. If you're running Blazor WebAssembly, for example, you are running literally inside of the client browser, and some things do not make sense to work there. So if you go and install some kind of NuGet package that needs to do something with the user's file system, for example, that isn't going to work, because you are operating in the same security sandbox as any JavaScript app. So you can't reach out to the user's file system and start playing around with files and stuff like that. But other than that, most other things just kind of work, which is pretty cool. Debugging, again, especially in the .NET world, we're kind of quite sport with tooling and things like this, and this is something we kind of expect really, and Blazor has this. So in Blazor Server, we've got first-class debugging. You can hit F5, run everything. We've just got that with Blazor WebAssembly as well, as it comes closer to its release date. I'll be honest, it's still not quite there yet. We can hit a breakpoint, for example, but sort of hovering over and looking at variables at runtime is a bit iffy, and like I say, it's a bit patchy. It's not quite there yet, but it's been there for a couple of previews, and it's got better in both of them. So I don't think we're a million miles away so far. So we've got JavaScript interop as well. Well, this is probably a weird one because most people associate Blazor with being able to get rid of JavaScript. I hate to burst that bubble, but that's not strictly true. As we're going to see later on, WebAssembly has a rather large Achilles heel at the moment, which is it can't do anything with the DOM directly. And that's where we need to use JavaScript. The other reason we need to use JavaScript, to be honest, is there are a lot of really good libraries out there that are well-baked, battle-tested, hardened, and frankly, it's just not worth repeating that code and recreating it just yet. So we can write nice C# wrappers around these libraries using JavaScript interop APIs. They're really simple, really easy to understand. And once you've written that wrapper around it, you don't need to care that it's JavaScript anymore. I've got another talk where I actually do some coding and show this. And, you know, once you wrap those components, you can just forget that they're JavaScript under the hood, which is quite cool. And the final one is assembly shaking. So this is something called an IL linker is responsible for this. And this kind of comes from the Mono team. And what this does is it kind of strips out, it analyzes your code, and it strips out everything that's not being used out of like the base class libraries and stuff like this to make the bundle size as small as possible. Now, this is not really relevant for Blazor Server, and if you don't know much about Blazor Server, you'll understand why when we go through that in detail a bit later. But for Blazor WebAssembly, where we're downloading a lot of stuff to the client, this is really important, and it really shrinks that bundle size very, like massively. So it's really important, and that's getting better over time as well. That's seen a lot of optimizations. So that's a bit about what Blazor is. So let's start sort of pulling the covers back a bit now and understanding a bit about how Blazor works. So first of all, I just want to say Blazor has a separation between how changes are calculated and how they're applied. Now, this is an important point I want you to understand because it's really what makes Blazor so exciting for me. It's a really simple premise, but it gives Blazor a lot of scope for use. So this is what I mean by this. So Blazor has its app model, its component model, and that's separated from what's called hosting models. Now, we refer to these as hosting models. So this is things like Blazor WebAssembly, Blazor Server. They're hosting models. In the code, these are referred to as renderers, okay? And what this kind of, I've got some sort of more detailed slides that kind of hopefully make the point a bit better. So Blazor's component model contains the kind of the main framework of Blazor. It's where things like the UI updates are calculated, stuff like that. But that's the part of Blazor that doesn't actually apply those updates to the browser or anything. It passes them on to one of those hosting models, one of those renderers to do that. So by default, Blazor has a web renderer. This knows how to render HTML, okay? So the UI updates get passed to that web renderer, and that web renderer then can display that, or can then pass them in and display them in a web browser, okay? But there is a separation, so we can do funky stuff like we can move that web renderer and actually run it on the client instead of on the server, and then we can just set up some kind of, you know, network connection between the two, SignalR, for example, and that's how Blazor Server works. Spoiler. The really interesting thing, though, is we can scrap the web renderer altogether and we can replace it with a different one. So one that knows how to render native UI, for example, native mobile UI, for example. So now the same sort of UI diffs get calculated and get past this render, except this time we get a mobile UI out of it, okay? But this isn't a mobile UI that's using HTML or anything like that. This is using native controls. So this is a really important point, and like I say, it's one of the key things for me as why I see Blazor as such an exciting prospect over the coming years. Okay, so let's talk about hosting models. So these are the two that you would have probably heard of: Blazor Server, Blazor WebAssembly. Blazor Server is the currently production supported version of Blazor. This has been around since September last year, so it's been around for a good while now. It came out with .NET Core 3. Full production support. And this is the model where Blazor runs on the server and kind of the browser is a thin client effectively. And we're going to go into detail about how this works in a little while. And then we've got Blazor WebAssembly. Now, this is the one that most people tend to get pretty excited about. And the reason is because this is the one where everything runs in the browser, okay? We're running C# code in the browser without using transpiling or Voodoo Magic, you know, whatever. It is true, genuine C# code running in the browser, okay? So this one's in preview. It's coming out in May. Okay, I'm expecting this is probably what you're going to hear about at Build. You know, that would probably be not a crazy guess. So we haven't got long to wait now. We should see a release candidate, I think, probably within the next sort of 10 days or so, I think, based on the schedules I was looking at the other day. So they definitely had a release candidate before the end of April. So hopefully we'll see that. And this is one we're going to go into first. We're going to go quite deep into this. I'm going to cover lots of concepts while we're in this one, and then I'll just touch on sort of where some of the differences are in Blazor Server. So before I do that, I just want to show you a bit about what a Blazor component looks like. So this is a Blazor component. It's kind of two halves. So the top half is the markup and the bottom half is the logic. Razor syntax is things like that current count. You can see it's being printed out there, that expression. There's also stuff like that on-click handler. Okay, it's got that little @ symbol at the front, and that's saying that it's a Blazor on-click event, not a JavaScript on-click event. And in this instance, it's saying when I click this button, invoke this increment count method, which is down there in the code block, along with that current count field. Okay, and that's just going to add 1 to the current count. Now you can do lots of things with these components. You can put everything all in one place like this. I personally prefer building components this way with the code and the markup together. That's actually, I think, believe what the Blazor team do as well. They prefer to do all this, and that's because the logic should be tightly coupled to the markup. It makes sense to have it all in one file. It's easy to edit and stuff like that. But if you want to, you can separate out that code block into a different file. So you can have just the HTML Razor code in one file, and then you can have the logic in a normal C# class. And you can do that in two ways. You can do inheritance. So you can have the logic in a base class, or you can do partial classes and kind of get that code behind style that if you did web forms, for example, it's similar to that. So there's lots of ways you can do it, whatever way suits you. The interesting thing though with Blazor components is if you've done any work with Razor before, they don't work the same as the rest of the Razor stuff that you're probably used to. So Razor Views, Razor Pages. Now Razor Views, Razor Pages, they're server rendering technology. So what happens is the Razor engine runs them, compiles them, and basically they spit out some HTML, and that HTML gets sent to the browser, and that's what's rendered. Okay. And they tend to be rendered as whole pages usually as well. Blazor components don't work that way. Blazor components are written in Razor, but they actually get compiled to a C# class. Okay, so this particular component, if you just take a mental snapshot of what that looks like, actually gets compiled to this. And this is actually what Blazor uses to calculate UI updates. So every Blazor component has this method called build render tree. Remember the render tree I was talking about right at the start? Well, this is the sort of first touch point we have for it. What happens is Blazor's sort of rendering algorithm calls into this method, passing in this builder, this render tree builder, and then all of these instructions get added to it, and then the rendering algorithm then produces a render, compares it to the previous render, then they calculate the differences, and then you get those change sets, which are actually called a render batch. But this is where it comes from. So yeah, like I say, I just want to point this out because it's a bit of a misconception from people who are coming from, like say, MVC or Razor. They expect components to just spit out HTML, and they don't. And this is also the reason why those hosting models and that component model for Blazor can stay separate, because there's nothing about this set of instructions that says it's HTML. You see, it's a lot of generic stuff: open element, open add content, add attributes. None of these things are actually HTML specific. Okay, so it just happens to be that the string in there is a div. Okay, but it could as easily be a stack layout, for example. Cool. So let's start deep diving. So we're going to go for Blazor WebAssembly first. So first thing we'll cover with this is WebAssembly. Couldn't really talk about Blazor WebAssembly without covering this. So what is WebAssembly? Well, WebAssembly is also known as WASM, which I love saying. It's a fantastic word to say. WebAssembly is a binary code format, and it's really fast. In fact, what WebAssembly promises us is near native speeds in the browser. That's quite a bold claim, but it really does live up to that. I mean, it's not quite there yet, but it's really making strides. WebAssembly is also a compilation target. Okay, it's designed to be a target for high-level languages. It's not really designed for you to write native WebAssembly code. Just to illustrate that, this is some WebAssembly. Okay, this is a C++ function on the left, and then this is what it looks like when it's converted to when it's compiled to WebAssembly. Now, technically speaking, this is not the WebAssembly that would get executed. Okay, WebAssembly is a bytecode format; it's binary. This is actually a textual representation of WebAssembly that's there for us humans to be able to sort of get a bit of an idea of what's going on. Now, it is actually okay. You can actually write WebAssembly using this textual representation, and there are people who have actually done that. It's not my bag. I'm probably not going to crack open Visual Studio Code and start churning away writing code like this, but you could do if you want to. I'd much rather write something sort of more closer to the left-hand side and have it compiled down. The other important thing to understand with WebAssembly is it's a web standard. It's actually now the official 4th language for the web. Okay, so back last year on the 5th of December, the World Wide Web Consortium officially announced that the WebAssembly core specification is an official web standard. Okay, so it rightfully takes its space now in the web alongside HTML, CSS, and JavaScript. So this is quite a big deal. This kind of, I like to illustrate this point because obviously with Blazor, there is often a lot of confusion from people who are involved in the Silverlight era. And this is why Blazor is not Silverlight. It doesn't run on plugins. It doesn't use any sort of external systems or anything like that. Okay, it uses standards and only standards to run. And also, as you'd expect, being a web standard, it is supported by all major browsers, including all the mobile ones. WebAssembly is not new. It's been around for a while now. It's been around for well over 2 years. Okay, it's been in all of the major browsers for over 2 years. The MVP was hit year ago maybe, and they're working on secondary features. Now, WebAssembly really is going to change the face of web development. At the moment in preview, you can use threading. So for the first time, WebAssembly has brought true threading to the browser. We've only ever had one thread before. Okay, but with WebAssembly, we'll be able to write true multi-threaded applications. So that's a really impressive and really interesting sort of prospect for web developers going forward. There's lots of other things coming as well, things like garbage collection. Okay, so WebAssembly will have a built-in garbage collection mechanism, which means other languages targeting it, like .NET, for example, won't necessarily have to rely on a full garbage collection solution, which lowers download sizes and things like this. The other interesting point is that part of the garbage collection spec actually includes DOM manipulation. Okay, and that's where things get really interesting because it's that will be the turning point where you don't need to use JavaScript for everything. You'll be able to manipulate the DOM natively through WebAssembly APIs. So how does WebAssembly fit into the Blazor world? Well, it's actually all to do with the runtime we use. We take the mono.NET runtime, we pass it through a toolchain called Inscripton, and out the other side, we're going to get a .NET.wasm file and a .NET.js file. .NET.wasm is the complete mono runtime compiled to WebAssembly. The .NET.js file, I mention it here, it's not actually particularly relevant per se. All it's there for is to bootstrap that WebAssembly runtime inside the browser, okay? Because we have to use JavaScript to load this stuff because of the shortcomings at the moment. One thing, again, I want to highlight here, your application is not compiled to WebAssembly. It's a common misconception. It's only the mono runtime that gets compiled to WebAssembly. We download that mono runtime as WebAssembly to the browser, and we download native .NET DLLs. Okay, they're not specially modified. There's nothing sort of fancy done to them. You could take them and run them on a .NET runtime on the server somewhere else. Doesn't matter. Okay, these are normal .NET DLLs, bog standard IL. Okay, and they are going to get executed using just-in-time interpretation effectively in the browser. So that's a bit about WebAssembly. Now we're going to have a look at how Blazor WebAssembly apps actually work. So we're going to go through the process of how a Blazor WebAssembly app actually gets bootstrapped. So how does one actually get fired up? So we're going to start off making a request to a web server. No big surprises there. And then we're going to get some files back. Now, importantly, we're going to get static files back. So a static HTML and index.html page, CSS, images, JavaScript, and that .NET.wasm file we just talked about. So this is the first interesting point about Blazor WebAssembly apps. We can use free hosting with this. We do not need a .NET runtime on the server. Okay, so you can run Blazor WebAssembly apps on GitHub Pages. You can run them on Netlify. You can run them on nearly free stuff like Azure Blob Storage or Amazon S3 buckets. It's not a problem. Okay, anyway, you can run static HTML. You can run Blazor WebAssembly apps. Now, when all those files hit the browser's going to do its thing. It's going to load up the DOM, and then it's going to fire up these files, the Blazor WebAssembly.js file, and in turn .NET.js that we saw earlier, and that is going to bootstrap that .NET WASM runtime. On top of that, we're going to run Blazor, and then on top of that, we're going to run your app, okay? On this diagram, everything above that orange divide is kind of WebAssembly / C#, okay? So there's the WASM file there, that's obviously WebAssembly, but the two purple boxes, they are C#. Okay, they're just normal .NET DLLs. And that's it. That's now a running app. We could sever the connection to the server. It won't matter. Everything's running in that browser. Okay, so it's a true single page application. Okay, with no reliance on a server element at this point. Obviously, if you want to make external calls to get data, we obviously need it. But right now, that app will just run. So that's how it gets going. Now let's talk a bit about how it actually updates and processes stuff. So we're going to pretend we've got this search component here. So this is what it looks like on the left. It's going to render this search results, okay? And what we're going to do is we're going to click that load more button, and then we're going to follow the process through of making an API call, getting some more search results, and then appending them to that list and how that works in Blazor WebAssembly. So first of all, we're going to click that button, and we're going to have that DOM event intercepted, and that's going to get passed up through all the layers to our handling code. So in our search component there, we're going to have something that handles that button click, okay? Now, in there, there's going to be some code that makes an HTTP call. It's going to use the HTTP client, the one that you know and love from C#, except in Blazor WebAssembly, that's got a sort of special HTTP message handler, which actually uses JavaScript and actually invokes the JavaScript fetch API to make that call. So what happens next is we actually go back down through the layers to this bit of Blazor that runs in the JavaScript world. Okay, so there's a little bit of Blazor that runs in JavaScript in order to coordinate all of this stuff. That's where the actual call gets made out to the web API. The web API is going to send the data back, and then that's going to get passed up through the layers back to the calling code that we started with in the search component. In there, we're going to update the list of search results. Okay, we're going to add the new search results to that existing list. That is going to change the state of that component, and Blazor is going to be aware of that. Okay, so what happens next is Blazor does a UI diff calculation, and from that, it works out what changes are needed, and it creates a render batch. Okay, and that's using that render tree we talked about earlier. Once that render batch has been calculated, it gets passed down to the bit of Blazor in JavaScript, and that is then responsible for updating the physical DOM. At that point, the view changes in the browser, and we see our new search results. So that's kind of the process of how this all happens. So let's have a look at a demo. Let me just skip over. I will go to here. I'm going to create a new project. So we'll go for a new Blazor app here. Blazor 50. I do this a lot. Cool. So I'm going to go to the Blazor WebAssembly app here. So first of all, I just want to talk about a few of the template options that we have. So if I just select this, and this is one we are going to create in a second, this will create a standalone Blazor WebAssembly app. Okay, so excuse me. Oh, we'll get single project, single Blazor WebAssembly app. However, if I want a API to go with that, for example, which I think in a lot of applications probably would, because usually you want to do something on the server, you know, persist something to a database, that kind of thing, then we can do that by ticking this box, ASP.NET Core hosted. Now, with this template, we're going to get 3 projects. We get the Blazor WebAssembly app, we will get an ASP.NET Core Web API, and we'll get a .NET Standard class library that is used to share classes between that front end and back end. Okay. If you wanted to do a PWA, so if you don't know what a PWA is, that's a progressive web app. And this is where an app can run offline. And this is where you can do things like save it to the home screen of like your mobile phone, and it'll act like a native app and stuff like that. In order to do that with Blazor WebAssembly, we just tick that box for progressive web application. That's going to create a service worker and a manifest JSON file. That's all going to be configured. And that is just going to be ready to go PWA. Okay, it's that simple. In terms of security, we can hit this change button up here under authentication, and we can go to individual user accounts. For Blazor WebAssembly standalone applications, the only real way we do authentication here is using OIDC, and that's why there's only one option available, is individual user account. So this would set up a standalone Blazor WebAssembly app that would use OIDC to talk to something like Identity Server or Azure AD B2C or something like that. So you can see straight away that it's sort of, we can get some quite cool templates with a couple of button clicks, which is pretty awesome. But for now, we're just going to go with standalone template because we're just going to focus on sort of what's in there and what's going on now. Right, I just need to move some stuff about. So just take a second to spin up. need more RAM. So, cool. How is that for everybody's eyes? Is that big enough? Is that coming through okay? Does that need to be bigger? I want to ping it in chat or... Okay, not okay. All good.
People saying
Bigger.
mixed opinions, slightly bigger. Someone's saying.
Right, let me try this. This screwed up last time, but let me see if this works. Right. Is that a bit better?
That's good for me. I think that'll be good.
Yeah, excellent. Cool. So we've got a few bits and bobs here in this template. We have a www root folder, and this has got static assets in here. So we've got the index.html, which is used to host the application. We have a pages folder, and this has got a few different pages with this Razor extension, and these are Blazor components. We've got this shared folder, and again, we've got something called a main layout, and that's a special type of component in Blazor. It's a layout component. We have a normal menu component, which is just a standard Blazor component, and same, the survey prompt, again, is another standard Blazor component. At the root here, we have the app.razor component. This is the entry point for the application, and we'll have a look at that in a second. That contains the router. And then finally, we have program.cs. You'll notice we don't have a startup.cs. That's because dependency injection and everything in Blazor WebAssembly is all configured in the program.cs file. So let me just come back out of that. Let me just open up this first of all. So in here, I'm just going to bump this up. Is that okay? It should be fine. Yeah, cool. So the reason we don't have a startup CS file in Blazor WebAssembly, something that actually got removed not very long ago, I think last month or the month before, is because it kind of doesn't really make a lot of sense. There's only two methods in a startup file in an ASP.NET Core app. Configure services, which is used to configure dependency injection, and configure, which is used to configure middleware. In Blazor WebAssembly, middleware, there isn't a concept of middleware because it acts more like a desktop app. Okay, once we run the app in the browser, we're effectively the only client, and it's stateful. So it is more like more like a desktop app in that regard than a traditional web application. So middleware doesn't really have a place because there is no request and response in that way. So having that method there doesn't make a lot of sense. I actually spoke to Ryan Nowak, who's the architect for one of the architects on the ASP.NET Core team at NDC London, and I was asking him specifically about this just after they removed it. And he said they removed it specifically because it kind of leads developers to think that there's something there that isn't. There were developers who thought there was actually middleware in Blazor WebAssembly, and there isn't. So they felt that once they removed that method out of startup, having startup with one method in it kind of didn't make any sense. So now we configure everything through the program main method. So you can see here we have a builder, and that has the services, which is a nice service collection, and we can just add all of our services there and do any stuff that we want to, all from this file. So that's why we don't have a startup CS. So before I go into detail about all the other bits, I'm going to just spin this up and show you what the app looks like when it's running, and get a feel for sort of how the interaction is, what's going on and stuff like that. We'll be a bit quicker in a second. Cool. So I'll zoom in on this a bit as well, just in case. So this is the standard template. 3 pages, home, counter, and fetch data. If I go on the counter page and I click here, you can see the counter goes up, and fetch data loads some weather data out of a JSON file. So it's mimicking doing an API call at this point. But in here, if I go to the browser tools and we go to network, you can see that there's nothing going on. Okay, I'm not making any requests. This is genuinely all running in my browser. If I've got caching disabled here and I do a refresh, and it's not going to do it because I didn't run it in the thing. This is there it is. Cool. That's me forgetting stuff. So you can see we've got all the static assets come down that we talked about earlier. We've got this Blazor WebAssembly.js file, and we've got this Blazor boot JSON, which helps boot everything up behind the scenes. We've got the initial document there, the HTML document, Bootstrap CSS, all of those things. Now, they've recently changed how the template works when you're running it in sort of a local development mode, where it kind of doesn't really, it kind of doesn't download the runtime stuff how it used to. So I'm just going to quickly redo this with F5. Now, this will take a little bit longer to boot up, but then we'll be able to see sort of more of the detail about all the bits and bobs that come down when you load the app up. Now, this will take a second because what's happening now is that it's actually establishing a debug session between the browser and Visual Studio. This is all part of the new debugging experience from Visual Studio. So that just takes a second or two to hook up, and now we've got the app running. So if I go in here and I'll just move this down here now, go to network, disable that cache. There we go. I'll bump this up a bit. Cool. So if we go up the top, we can see that there's that initial document coming down that we talked about, CSS, Blazor WebAssembly.js, and then further down here, we will have this .NET preview file here. This, no, that's the wrong one. Hold on. Where am I going? Oh, it still hasn't done it. It does it in that thing now, doesn't it? Sorry, they've changed all this. And like I say, it used to show the WASM file, but it's not doing it now. Weird. Anyway, what you can see though is all the DLLs. So app50.dll. So that's obviously the project that we've got in here. And then after that, you've got a load of system DLLs. Okay. So systemnet, HTTP, system buffers, MS core lib. Okay. These are all the normal .NET DLLs. Okay. And they're just going to get executed on that WebAssembly runtime. You can also see down here, it's 6.5 meg, which is pretty damn huge. That's because it is downloading that whole WebAssembly runtime. It's downloading all of these DLLs. They're not being tree shaped. Okay. So running locally now, it's been designed for speed. So we kind of don't do IL linking and all that. We wait for that till we do a release version. Okay. So 6.5 meg in debug mode. And the console actually tends to spit this stuff out. So it'll actually tell you now that it's loaded 6.2 meg of resources. So you can sort of see quite quickly, like sort of how big your apps are. However, if I go here and I change this to release and I run this up again, we'll have a look at the difference it makes when that IL linker runs. Cool. So I'll disable that cache and reload it. 2.1 meg. So that IL linker really does a lot of heavy lifting. It does a very important job. Now, that can go as low as 1.6 meg. But at the moment, things like the Bootstrap CSS take up a lot of weight and stuff like that. So it all depends. You can see down here now we're running in production mode. We can actually see that WASM file. Okay, and this is that .NET runtime. If we go across here, I did just see someone in the chat ask how big files are. So I'm assuming this is the files we're talking about. So that full .NET runtime is 778K. So that's pretty impressive for a full .NET runtime. It's obviously pretty hefty from a web world point of view, but I think that is very relative to the type of apps you're developing and what your user base is. The other thing that's important to point out is that these apps are a one-time cost. So that WASM file will get cached, all those DLLs will get cached. So only changes can be downloaded. So once I've done this once, if I disable cache and I refresh the page and you check out at the bottom now, I've downloaded 34K. Okay. And that's because all that WebAssembly runtime, that's all been cached. It's not coming down a second time. Okay. So it's all still pretty efficient. And things like CDNs will lower this cost as well. Things like that, that .NET runtime can live on a CDN. So if you've been to any other Blazor app, you can just sort of, again, load that from cache. So we can offset a huge amount here. So I personally don't see size being a huge issue. So come out of that now, and let's have a look at some component stuff. So we're going to look at the this index page. First of all, actually, no, I'll tell you what, we won't. We'll start with the app. So this is the entry point to the Blazor application, okay? And this is where the router lives. Blazor's router is responsible for basically loading the correct page component for the route that we're requesting. Now, what happens is when a Blazor app starts up, the router uses reflection to scan the assembly, and it finds any component that has a page attribute on it. Now, that's kind of the high level. Technically, it actually looks for something with a root attribute on it, and that's the compiled class that comes from a page component, but we won't worry about that. So when it finds one of those, that gets loaded into this found template here by the root view component. If we can't find one, then we display this layout view with this message, okay? This is what makes a page component, a page directive at the top. The page directive has got two halves. The first half is the declaration of the page directive, which is that at page. And then the second half is the template that this particular component is responsible for. So this is a /. So this is basically saying it's the root page. This is our home page, if you like, for our application. In here, you can see we've just got normal HTML. We've got an H1 tag, some text, and we've got this green survey prompt. So this is that other component I pointed out a second ago in the shared folder. This is a normal Blazor component, okay? So what I mean by that is it's not a page component. And this shows sort of how we can build APIs, nice APIs around components. So we can see here that it has this parameter called title, and we can pass in a title that we want this component to display. So what I'm going to do is I'm just going to get a version of this running again. And we can see here, this is where that title's been displayed. How is Blazor working for you? Okay, so I can say, like, I don't know, something like, I can change this to something saying like, how cool is Blazor? And we can run that. If I go back over and refresh, it hasn't gone through yet. And that's rubbish. There we go. I think my machine running Zoom is not liking this with its 16 gig of memory. There we go. Cool, and then we can see that update, okay? So we can create nice APIs for our components where we can have consumers have very sort of defined ways of changing the sort of internals of our component and what's being displayed and stuff like that. This is really cool when you start looking at things like creating reusable components like tables and modals and all this kind of cool stuff. So that's pretty decent. So that's kind of the bits I wanted to point out in the index page. In terms of the counter page, we've got a bit more going on in here. So first of all, you can see what a sort of a more interesting page route looks like. So here we're saying when we go to the /counter, we navigate to /counter on our site. This is the component that needs to be loaded. You can see in here, we've got this on-click handler. So this is the component I was showing in the slides earlier. So when we click this button, it's going to increment that count. And we saw that earlier when I was clicking through on the site. And we saw that going up by 1 each time. So that was good. So we can do other stuff here. So I'm going to sort of play around with some other bits here. So we can sort of change how much we increment it by, for example. So in here, we're going to do increment amount, okay? So down here, we're going to go plus equals, if I could type, plus equals increment amount. Okay, so we're going to, every time we click this counter now, we're going to want it to change by however much we set. But we want a way to define that. So we haven't really got anything for that right now. So I'm going to just nab some code. Cool. So I've just got a p tag here, and I'm just saying, here's the increment amount. I'm just going to print it out so we can see it as we do it. And now I've got an HTML input, and I'm using something called the bind directive. So this is how you can do two-way binding in Blazor, okay? So just say bind, and then whatever the particular field you want it to bind to. So I've got this field increment amount down here. And that's it. Now, if this had a value, that would start, that's what the input would start off with, or every time I change it inside of the input, that's going to change it there. You can see where I'm going with it. So I'm going to rebuild that. Just as a point, Blazor WebAssembly standalone templates are the only templates at the moment that don't have an automatic recompile. So if you are doing Blazor development with either a WebAssembly hosted app or a Blazor server app, once you've got it running with Control F5, if you make any changes to the code, you just need to refresh the browser and it will automatically do a rebuild. Cool. So let me just reload the app for that. so in the counter now, we now have our increment amount. So if I change that to 10 and tab out, you can see that that's automatically updated that value there. And now when I start clicking, we get 20, and I can change that to 100, and I start clicking, it goes up like that. So that's quite cool. You'll notice that the binding happens on a certain event. It happens on the blur event. So you can see I can change whatever I want in here. Nothing really happens until I hit tab, okay, and I move out of that box. So by default, bind only updates on blur. But we can do stuff like we can change that around. So at the moment, bind is, let's say, using blur by default. But I can actually say bind, and I can go colon, and I can say which particular event I want bind to work with. So on here, I'm going to say I want to use on input. If I can type. Cool. So I'll just rebuild that one. So if I refresh this now, and I go in here, you will notice, as soon as I start typing, updates happen straight away. Okay, so I manipulated the event that bind uses. So that can be quite useful. That's actually something that, for example, I have a type ahead component. That is key to the type ahead working, because I need to check for stuff every time a new key press comes in. So being able to sort of bind to different events in a nice, easy, succinct way is quite important. And I quite like the APIs that Blazor has for this. So that's quite useful. That's quite interesting. But I don't want to sort of continue with that. So we're going to get rid of that. I'm just going to grab my notes for this one. So we're just going to update this now to something else. So same as it was before, except this time round, what I've done is I've got another event here. I've got the on key press event. So this E, for example, here, this is the event args. So if I wanted to over here, I could say E dot, and I can get IntelliSense, and I can see information about the key that was pressed, whether there was a meta key held down, all the normal stuff you'd expect if you were doing this in JavaScript. Okay, you can get hold of that. But for now, I don't really care about what is in there. All I'm going to say is on key press, I want to increment the amount. Okay, that's all I'm going to do. I'm not going to do anything more than that. Cool. So this time round, if I go over here and I'm going to press G. Okay, I know you can't see my keyboard, but trust me. You can see that now, hitting the G key, I'm incrementing that amount, okay? The only problem now is I have a G in my box, which doesn't make a lot of sense because the default event is happening, which is the key press event, and therefore I'm getting that key character. But again, I can deal with that. So what I can also say is on key press, in fact, I want to say on. I actually want to prevent the default action. If I rebuild that.
We just had a question. What's the difference between bind and bind value?
That's a good one. I'll do that next. Hold on. So let me just quickly refresh that. If I go here now, I'm going to press G again. And now you can see I'm not getting a character come through. Okay, I'm just getting the count increment. That is a completely useless and pointless demo. There is no reason why you'd want to do that. But it does just show how you can manipulate what are traditionally JavaScript-only events using pure C# code. Okay, that's the point I'm trying to make here. So yes, to come to that question, what is the difference between bind and bind value? So the simple answer is absolutely nothing. Bind is a shorthand for that. Okay, only works with inputs. So what this is, well, it's not technically true. What bind does when you use bind against some kind of input control, whether that's an input or a select or something like that, if you use bind on its own, it will bind to whatever the kind of traditional standard sort of value equivalent is. So in a text box, or in an input, if you were going to hard code this, you would say value equals 4. Okay, so that is what this part of the bind statement means. This value here, it's saying bind to basically this value attribute on the input, and that's where we're changing it. If you obviously we do that a lot, and that's why the team sort of allowed that syntax where it just kind of assumes that's what you mean if that's what you're on. What you do have though, this bind equals, and then you can bind to other things. So it tends to be something that with native controls, you don't tend to do a lot, but when you're writing custom components, you do it. So what I will do is I'll show an example. So input text is the built-in input component for forms that comes with Blazor. Okay, this is built in. This is what comes from the Blazor team. Now, to bind to this, you don't use bind value with a lowercase v, because that's reserved for the HTML control. You use it with an uppercase v, okay, because that's the parameter that's exposed by the text input component that's wrapping the native input component. I hope that makes sense. A couple of people who I can see are nodding, so I'm hoping that's not too convoluted. So really that bind statement all comes down to which particular event it is that you want to bind to. And you can define these in your own components. There's a whole way of doing this using something called event callback args and stuff like that. It's all available in the docs. It's probably a little bit sort of out of scope for this, but if people want me to, I can definitely dive into that, maybe at the end. So yeah, but that's what that means. Does that make sense? Cool. At the current version, is there support for scaffolding models into pages like MVC? No, there's not. I don't know if scaffolding will come in anytime soon, if it comes in at all. I know it's not on the roadmap at the moment, mainly because there is just a lot of other, frankly, more important stuff. And scaffolding is really useful, but frankly, it's a time saver that you can kind of get from third-party stuff. I would expect someone from the community will put something out before you get something official, I would expect. The other interesting thing is it depends what you want to scaffold. In Blazor WebAssembly, because scaffolding traditionally, let's take the MVC version, for example, you would usually give it a database entity and it will scaffold out a load of CRUD pages for you. In Blazor WebAssembly, for example, that won't make much sense because you can't access the database. You're running on the client browser entirely. You need to make API calls to get to the browser, to get back to the database. So scaffolding doesn't make a lot of sense in that scenario. It probably makes a bit more sense in Blazor Server where everything's running on the server. But even so, it all depends what you're trying to achieve, and yeah, it's all a bit iffy. But yeah, I've kind of waffled it. But the simple answer is at the moment, no, there isn't anything built in. Cool. Excellent. So that's a bit about how binding works and about how we can play around with events and produce something that's a bit pointless for a demo, but you know, it's all fun. So that's that one. The last one I'm going to show you is the fetch data component. So this one's a bit more involved. So at the top here, we've got a different directive. We've got the inject directive. So this is how we do dependency injection into Blazor components. So here we're injecting the HTTP client. We've got a bit more interesting markup here. We've got some more sort of I guess more advanced razor. So we've got an if statement that's if the forecasts are null, it's going to render this bit of code. Otherwise, it's going to render this table. And then we've got a for each statement here. It's going to iterate over this forecast collection and print out each forecast as a table row. So this is pretty standard how you'd be doing stuff in Blazor. In the code block at the bottom, we've got sort of all of the other bits for that. So we've got that forecasts collection down here. We've even got a class defined, okay? So in that code block, it's all C#. So as long as it's valid C#, you can write it in here. You can define classes in here if you want to, stuff like that. It's all good. The interesting part here is this on-initialized async. So this is one of 3 lifecycle methods that Blazor components have. On-initialized, on-parameters set, and on-after render are the 3. So on-initialized only runs once in the lifecycle of a Blazor component. And as you could probably guess from the name, it is used to initialize stuff for that component. So here is pretty much the classic example, making an API call to get the initial data set that the component's going to use, okay? Once that's run, it's not going to run again. So you can't kind of do anything that iterates. Now, the other one that we've got is on-parameters set. Now, normally I just talk about this, but I think it's, frankly, I think it's a bit more easier to show it. Obviously, if I can type it. So these all have sync and async equivalents, by the way. So either on-parameter set or on-parameter set async. Now, this particular method fires a lot more often than on-initialized. It fires every time a parameter, so an incoming value to the component changes. So we specify incoming parameters like this. So remember that title that I was manipulating on that survey component? That is exactly what it would look like. Okay, that's how we declare an incoming component. So it's how we, I guess, declare the API for our component. What happens is, if you've got a component that's being dynamically updated, so parameters are being passed to it, when a user clicks on something, it updates a value, gets passed down from a parent or whatever. This value changes. At that point, this method fires. Okay, so it doesn't fire if you've got five parameters on your component. It's not going to run 5 times when one of them gets updated. It will just run once when any of them gets updated. It's up to you to work out which one changed and then do something about it. So you do have to be a bit mindful of that, and it all depends what you're looking to do. Okay, but that's what that one does. And then the final one that we have is on after render, and that has this bool first render in it. Now, this lifecycle method is specifically there for doing JavaScript interop calls. And the reason it's there is because you want to make sure that your component has actually rendered before you try and execute any JavaScript. And that's because you need the actual elements available in the DOM in order for JavaScript to be able to do something with them. Okay, so never ever do any JavaScript interop outside of this method. It is technically possible if you're on Blazor WebAssembly. It will blow up a Blazor server app, okay, because it gets pre-rendered. At that point, there is no DOM, there's no JavaScript, and then it all goes horribly wrong and it melts and it's not good. So yeah, always use on after render to do JavaScript interrupt calls. And what you've got there is that first render. Now, that first render, again, is there specifically to handle pre-render scenarios. So what you can do is you can say, if it's the first render, return. I don't do anything because it's happening on the server and I haven't got any JavaScript to interrupt with at that point. And then you can put any of your actual interrupt code outside of that or inside of it, depending on which way around you want to do your check. Okay. And that way you can make sure that you can do pre-rendering and not have a load of issues about JavaScript runtimes not being available. So they're the 3 lifecycle methods and a kind of whiz-bang tour of what you can do with them and how you can use them. So we'll get rid of those bits. So that's kind of the bits I wanted to show you in there. The main layout as well, I'll just quickly point this one out. So this is a special type of component. It's called a layout component. This is very similar to anything you would have seen in sort of layout-wise in MVC and again in Razor pages. You can define your layout for your page, sort of your template, if you like, and then you specify this body tag here, and then that's where any components are going to get loaded. So those 3 page components we've just been looking at, they get loaded where this body tag is, okay? And you can specify these in different places. So by default, if we go back to the app component, it's specified, the layout is specified here with this default layout parameter on the root view component. So we could change that if we want to use a different layout. But we can specify this once here. Now every page component in our app will now use this main layout. However, if we want to, we can go into a specific component and we can use the layout directive here, and we can just give it a different one, okay? We can go in there, and obviously I'm just using the same one because I've only got 1 layout component, but if I had a different layout component, I can just do that, okay? In fact, I don't actually think I need to type off. I can just do that. So if I want to override this at a page level, I can, so I can have different layouts for different pages depending on what I want to do, but I can sort of set it globally and have everything kind of taken care of for me. So lots of flexibility there as well, as you would hope and expect. Cool, so that's kind of a whistle-stop tour. I don't think there's anything else I want to go over on that one, so we will jump back over here now. So let's just summarize some of this stuff. So firstly, runs on the client. So this is cool. We can offload work to the client. We can use the client CPU. We can save some cycles on our Azure credits and stuff like that. It helps with scalability. If you know, it's going to lower the strain in your server. Again, we can use lower powered instances on Azure or AWS or wherever. We can make it work offline really easily, okay? We saw it's trivial to make a Blazor WebAssembly app into a PWA. We literally just have to tick a checkbox and that is it. We have now got a PWA. It's deployed as static files. So again, something new for us in the .NET world. We can now use free hosting or nearly free hosting, depending on what we want to do, because we've just got static files at the end of our publish process. And code sharing, like I say, I can't hammer this one enough. If you're using C# on your back end, it makes building rich client-side applications so much easier when you can just share the same models. My team, for example, at work, we've been building with Blazor since the start of last year. We're a big fan of Mediator, commands and queries. We actually share parts of our commands and queries with our front end as well, which really streamlines building applications. So that code sharing is fantastic. As I said, it's currently in preview. We haven't got long to go now. I'll soon be able to take this off this slide, which is great. Payload size, 1.6 to 2.1 meg, depending on the composition of the app. To give you a bit of an idea of what more real world stuff looks like, my team have just converted a React app that's kind of like is what we're calling a My Account portal. It kind of, I work for a housing association, and it's for our tenants to be able to log in and do things like view their rent and make payments and this kind of stuff. So kind of typical, application you'd be doing. We've taken that from React, which was 1.4 meg. We've written it into Blazor and it's 1.6 meg. Okay. So size-wise, there's not a massive difference between the two. And we've still not done some bundling and minification that we can do in Blazor yet. So I'm confident that by the time we're done, I don't think we'll be as small as the React app, but I don't think we're going to be within 100K, 150K of it. So it's not bad. However, load time could be an issue, depending on how slow the particular end user's connection is. They have got to download all of those bits before it can be bootstrapped in the browser. So obviously that can't happen until they've got it. So you can do the math. And also you are on a restricted runtime. Okay, you are limited by the browser sandbox. Okay, so it's not restricted by the Mono runtime. The Mono runtime is fully functional. It does all the fun stuff. It's just that when you're in the browser, you are under the same security restrictions as any JavaScript SPA application. Cool. So that was Blazor WebAssembly. Okay, and there's a lot of stuff we talked about there. So we're now going to sort of move over now and talk a bit about Blazor Server. So this one won't be as long. We're going to go through the same process really and see sort of the differences between the two. So Blazor Server, the key thing to remember here is Blazor is running on the server, hence the name. So our Blazor application is up there. And what's happened is now we're going to make our requests like we did before. Except this time around, when we get stuff back, we're going to get compiled HTML. Okay, we're not getting static files this time. Okay, and we're going to see how that works in the demo in a second. But we do get the normal CSS, images, JS files. You'll notice again, there's no WebAssembly here. Okay, in Blazor Server, we don't use WebAssembly at all. We're running entirely on the server. We are running on the full ASP.NET Core runtime, or full .NET Core runtime, sorry. Now, when all these bits get into the browser does its thing and it executes this file called blazorserver.js. This has a couple of jobs, but the main one it has is to establish a SignalR connection back to that Blazor instance running on the server. So this is very much your kind of thin client style architecture. From this point forward, the app is now running. Okay, it's now established, it's working, it's ready to go. Anything that happens in the app now is going to get sent over that SignalR connection back to Blazor on the server, and then any updates can get sent back to the browser over that same SignalR connection. So let's go through the same process we went before. We're going to update our search results like we did and see how this works with Blazor Server this time. So again, same thing. We're going to click on that button and that DOM event is going to get intercepted by that small Blazor runtime that's running on the client. Okay, that same one that established that SignalR connection. That event gets transmitted back to Blazor on the server, and again, it passes up through the layers into our search component where our handler is. Okay, same handler that we had in the WebAssembly version, except we're probably not going to use an HTTP client here to make another API call because we're already on the server. I mean, we could call another API if we wanted to, that's fine. But chances are we're probably just going to use a repository or a service or a query to go and get the data from somewhere directly from a database service, whatever. Again, when that comes back, we're going to update that list on the component. Again, that triggers a state change. Blazor is then going to do another UI diff calculation, just as we saw before. And again, it's going to produce a render batch just like it did before. Except this time around, that render batch gets transmitted over that SignalR connection to that runtime on the client, and then it gets applied to the DOM, and that's when we see the change in the client browser. So genuinely, everything is happening on the server, bar the one thing that can't, which is the actual manipulation of the end user's DOM. So that's a whistle stop with that one. There's not a lot to go through because we covered a lot of it in the other one. So we'll go straight into another demo. So we'll close down our Blazor WebAssembly app. We won't bother saving any of that. And we'll create a new one. So we've got Blazor app here and 51, and we go with the Blazor server app. So again, this one, we've got Docker support, a click, just like you have with other ASP.NET Core apps. So we can just click that button if we want to and get Docker support. Again, talking about authentication, we've now got the full array of stuff here. So we can go to individual user accounts, and this is going to give us the ASP.NET Core identity framework all built and plugged in, and we can build an app using that if we want to. We can connect to a remote one if we want to on the cloud. We've got work and school accounts, so we can connect through Azure Active Directory, Office 365. We can go single organization, multiple organization, all that kind of fun stuff. And we've got Windows Auth. Okay, so all the stuff you would expect, you've got access to at a couple of clicks. So we'll create this app now and see what this one looks like. Cool. So over to the side here, there's really not a lot of difference, okay? One thing you'll notice, there is actually a startup CS file this time. That's because we are running on the server, we have a full .NET Core runtime, and we are far closer to a normal request response model. So we do have middleware. We could have this run APIs, we could have it run all the normal things that an ASP.NET Core app could do. There's just a few sort of key things that set up to make it work with Blazor Server. One of it is in the configure services method, this add server-side Blazor call, that sets up all the services in dependency injection. And then down here in the configure method, we use endpoint routing now. And the key point here is this map Blazor hub. Down here, this sets up the SignalR hub for communication with the client. And then this other endpoint, this map fallback to page underscore host, okay? And we'll have a look at that next. So that's found in the pages directory. And you'll see this is a CS.html file. So this is a Razor page, okay? This isn't a Blazor component. And this is the host page for our Blazor server app. We don't have an index.html. And this is why I said on the slide a minute ago, we're getting compiled HTML back from the server this time, not static HTML. This is going to get compiled and run like a normal Razor page would. This is also what allows pre-rendering to be on by default with Blazor server. You can see down here, we're using this component tag helper. And we're saying that the entry point for our app is the app component, and the render mode by default is server pre-rendered. Okay, so that's all turned on by default for you when you start a new application. Other than that, though, this is basically everything that we just saw. Okay, so we've got the app component that we saw before with the Blazor router in it. That's no different. We've got the index page that we had before. That's no different. Fetch data, that's mildly different. We're injecting the weather forecast service this time instead of an HTTP client, and we're getting the data from the service now instead of from an HTTP call. Makes sense, we're on the server now. You can see that we can use using statements inside of Blazor components, okay, just like we could do in C# classes. The counter component, again, exactly the same as what we saw last time, okay, nothing different there. It does have this data directory, that's got the weather forecast service in it, okay, so there's nothing exciting about that. That's just a sort of bog standard bit of boilerplate service just to show off what that does. But that's it. One thing I didn't show you in the Blazor WebAssembly app is the imports.razor. This is a place where you can specify using. So someone asked me this in the last talk I did, and I realized I don't ever really point this out. Instead of having to clog up your components with loads of using statements, you can put them into this imports.razor file that sits at the root, and every component will then inherit it. Okay, so all these using statements will be made available to every component in your app. You can also put this at nested points throughout your app as well. So if you wanted some using statements to only be available to your page components, for example, you could put an imports.razor inside the pages directory, and then only the components in that directory would get those using statements. So you can do that however you want. While we're here as well, I will make the point, there is nothing about this structure that is convention-based. Okay, so even though there is a pages folder that has the page components in it, and there's a shared folder that has shared components in it, that matters, it's absolute diddly squat. It doesn't matter at all. I could rename this folder to foo, it won't matter. Blazor will find those components using that page directive and using reflection. So I, for example, don't like sort of separating things by type. I much prefer a feature folder way of building UIs. It works really well, it scales really well, and it makes changing stuff really easy because I put my SAS file, I put my Blazor component, I put any subcomponents that are related to that feature all in one folder. And now when I make changes, I can get everything in one place. I don't have to keep jumping around. If anyone's done an MVC app that uses separation by type, they'll know what I'm talking about. I worked on a big app that had like 100 controllers in it. And scrolling through 100 views is not fun trying to find the one that you're looking for. It gets painful pretty quick. So yeah, so that's what the imports does. But outside of that, let's spin this one up and we'll have a look at, we can actually see all of that fun stuff going on over that Signal R connection. So here's our app. Now you'll notice, first of all, if I click about, this is just as snappy and responsive as the WebAssembly one was. Now, hopefully that works, that comes across over a video call. I will put money on it. If I gave you Blazor Server and Blazor WebAssembly next to each other and I didn't give you access to the browser tools, you would never ever know the difference between the two, okay? Blazor Server is still considered a SPA application, okay? Still works the same way, just happens to be that the diffs are calculated over there, not in the browser. That's really the only difference. So I can click here, I can get a counter, it all clicks around, it's absolutely fine. If I open up the browser tools, just to be completely honest about this, you can see I'm clicking this, there's nothing going back and forth over normal network connections. What is happening is that is going back and forth over a WebSocket connection. So I've got that open now. If I just do a quick refresh. Firstly, while I'm here as well, we'll point out 164K to load this up as well. So you know, it's because we're not having to download that .NET runtime and all those DLLs, the initial package size is obviously much, much smaller. Now, in here, you can see that Blazor Server.js that we talked about earlier. But let me just zoom in a bit. More importantly, down here, we have this WebSocket connection, okay? And that's what that Blazor Server.js file has established for us. So what I'm going to do is I scroll this up a bit. I'll try and get the most space I possibly can. I'm going to go to the home page. I'm going to clear out the binary messages. I'm going to click about a bit. So I'm going to click counter. I'm going to click that twice, okay? Now, you'd have seen that these binary messages have been racking up, and that's all those diffs and events being sent back and forth over that Signal R connection. So if I scroll up to the top, these are actually pretty cool because we can see what's going on. So if I click this one, we can see this is the first event. So this was me clicking that counter link in the menu. So we can see here, it says dispatch browser event. And if we go down a bit further, we can see that it was a mouse event, and we go down even further, we can see it's a click event. We can see XY coordinates down here of where I clicked on the screen. We can see other meta information, like if I was holding down the control key or the shift key or whatever like that. And down at the bottom as well, you can see it's tacked on this on location change request where I'm saying I want to navigate to /counter, okay? So that's everything that's happened about me clicking that link. So I'm not messing about. Genuinely, every single thing that I do is being sent back to the server to be processed. Now, if we go down through a few more of these, we will find a render batch. And I talked about those when we were going through the slides, okay? So this is a collection of UI updates. So each UI update is a singular thing, and that will be something like updating an H1 tag, for example, okay? And they're broken down into individual steps, but it's very inefficient to transmit each one individually, so they get bundled in a render batch that has multiple ones in it. If we scroll down, we will see the minimum amount of changes that are needed to make the home page become the counter page. So at the start here, we have an H1 tag with a string of counter. That is there. We have a P tag with current count of 0. That is our P tag that had an original current count of 0. Next, we have a button. We have a class on that button of BTN, BTN primary. These are two classes that come from Bootstrap. If anyone knows Bootstrap, you'll know that's why it's blue, because it's got BTN primary on it. It has an on-click handler, okay? So that's sent down because that's something that the Blazor Server.js file needs to know about, so it listens for events. And then it has the text of click me, which we can see in here, okay? So you can see that is the number of changes that Blazor's render tree has calculated are needed to make the previous render look like the render that we need it to be now, okay? And this is why Blazor Server is still a single page application, because it's taken the original page and it's just manipulated what's in it to make it look like the next page. Okay, it's giving that illusion of navigation. Can you see any use cases post WebAssembly release where we might utilize both Blazor Server and Blazor WebAssembly in the same app? I'll be honest, I personally don't see a use case for it now. There was a period of time where using both at the same time made a bit of sense. The WebAssembly debugging experience was horrific, and you could push all of your components into a Razor class library and do something similar to what Xamarin does, where you could have a Blazor WebAssembly shell app and a Blazor Server shell app. And then depending on which one you set as a startup project, you would either be running in WebAssembly or server mode. My team used this, actually. We used this for a while, where we developed using the Blazor Server app. And then in our CI pipeline, we deployed a Blazor WebAssembly app. Okay, so that was quite cool, really easy to do. You do have to do a bit of gymnastics around your dependency injection, because services that work with WebAssembly where you're making HTTP calls, for Blazor Server, you probably don't want to do that. You want to use a local service, and so you just use DI to substitute interfaces. It's not difficult, but you do have to do a bit of jumping for it. However, what that has spawned is some people to think that it would be a good idea to have parts of their Blazor app be Blazor Server and parts be Blazor WebAssembly, and that is just not a good idea. I genuinely can't see any reason why you would want to do that. Once you have paid the cost of downloading everything to the browser in Blazor WebAssembly, you've already paid that cost. So just stay there. And if you maybe have a requirement, like someone said to me once, well, I've got intellectual property that I don't want downloaded to the client. Well, don't use Blazor WebAssembly at all then, okay? Because all your DLLs get downloaded to the client. They can be decompiled. They can be looked at. If you don't want that code to fall into someone else's hands, use Blazor Server, because all your code stays server side, okay? Maybe if I have a component with, I need to hide the code. Yeah. I hadn't read that before I said that, but yeah. So if that's the case, use Blazor Server, okay? If that's the case, then do that. That's what I'd say. Carl, did that answer your question? Okay. I'm going to take silence as a yes.
Yeah, let's assume yes. Oh, yeah.
Well,
here we go.
Why would you use WebAssembly over Blazor Server? That's interesting, because usually the question I get is, why would I use Blazor Server over Blazor WebAssembly? Oh, that's interesting. I haven't had it this way around. It really depends what your use case is. If you want to offload load to the client, if you want to use free and cheap hosting, use Blazor WebAssembly. If you want to do things like, in-browser games, stuff like that, things where it kind of really helps to have everything running locally on the client, again, Blazor WebAssembly. If you want to do PWAs really easily, Blazor WebAssembly. Blazor Server, Blazor Server is great. I genuinely, I'm not in either camp. There's good use cases for both. My team has built Blazor WASM and Blazor Server apps. We like both of them. We tend to use Blazor Server for sort of small apps that run internally. It makes a lot of sense because we need that stable connection. Blazor Server is great, but it really becomes very flaky with a dodgy connection. What will happen is it's not really great, not really easy to mimic. If I set it to offline, it kind of doesn't really do it. What happens is when Blazor WebAssembly apps lose connection, they get this kind of white translucent overlay that says they lost connection and they're trying to reestablish it. It's not a nice user experience. The user literally can't do a thing while that's happening because everything gets calculated on the server. So the user's dead in the water. With a Blazor WebAssembly app, if you lost connection to the server, say because the user's on a mobile device, you can deal with that locally somehow. As a PWA, you can manage that to a degree, depending on what it is precisely. So it really does depend on what your scenario is. And to be honest with you, some of it's just personal choice. If you prefer dealing with sort of more server-based applications, then go Blazor Server. There's no real issue. It's completely up to you. There's no right or wrong answer. In some other Blazor talks I've heard, not all libraries are available in WebAssembly as of yet. and as such has to be done with Blazor Server. Chris, is that your understanding? I've never ever heard of a library that isn't available in Blazor WebAssembly. The only ones I will say, Jason, is, as I mentioned earlier, when you're running in the browser sandbox, you cannot do certain things that involve playing around with local file systems, for example. So the only thing I can think of with that is whoever was talking about that, whether they were talking about that kind of stuff. If you're running Blazor Server apps, because you're on the server, it's your file system, you can do stuff with the file system. So if you've got a library that's doing some stuff like that, then yeah, that wouldn't work in Blazor WebAssembly, but that won't ever work in Blazor WebAssembly. So it's not that it isn't available yet, it just isn't possible. Other than that though, everything should work. There should be no differences. There's nothing, so again, this is probably a good point to make. There is no difference between the components that run on Blazor WebAssembly and Blazor Server. Okay, they're entirely identical. There is nothing special about them. So they are completely interoperable. You can take one from one hosting model, put it on the other. They execute exactly the same. The only thing that makes them possibly bound to one hosting model is what you use to access data. So like I say, if you, for example, on Blazor Server, you could, please don't do this, you could inject a DB context directly into a component, and you could directly save and query your DB context from your Blazor component on a Blazor Server app. That is perfectly doable. Don't do it, don't do it, don't do it. You could do it though, but don't do it because it's really bad. Okay, it's a complete mix of concerns. One thing that's key with Blazor is completely and utterly a UI framework. Okay, we don't have one of these in .NET. We do not have one. We haven't had one before. MVC Razor Pages are not UI frameworks. Okay, they are server frameworks for rendering HTML. That is completely different to a UI framework. Blazor is a UI framework. So it fits in the view part of the MVC model. So it should only be doing view logic. It should not be talking directly to databases. So I'll get off my soapbox on that one, but anyway. So yeah, so that sort of stuff you can do. So that's again, and that's the only thing I can think of where that's coming from, or possibly someone was just a bit mistaken. I'm not sure, but yeah. Did my waffle solve those problems? All good? Yeah, thanks. Okay. Oh, how would you test a Blazor page? Ah, interesting. You can test them. So at the moment, there's no official testing library available. Okay. Steve Sanderson has released a prototype library that works. But the one that's really a big deal at the moment is one called BUnit. So that's actually done by a friend of mine called Eagle. He did a talk on it, in fact, at the .NET Conf Focus on Blazor event in January. It's a framework which kind of allows you to do different things. You can actually write unit tests for your Blazor components in Razor in a component, or you can use sort of the more traditional C# way, and you can use a test harness to mount components in C# and do stuff like that. Let me see if I can bring up the link for you. So this is BUnit. You can do C# based unit testing with this. So let me just zoom in. So this is the counter component that we were looking at earlier, and this is how you could test it. So you can write normal stuff like you would do with XUnit or something like that. You have a component test fixture base that you inherit from, and then you just use normal testing. So initial HTML is correct. You use this render component helper. You specify the type of component, and it renders out the actual HTML. And then you can do things like manually sort of specify what the HTML should be, and you can compare that the markup matches. You can do things like find and click buttons, and then you can check that the count has changed to the correct version, correct number, stuff like that. So you can write them that way, or you can use this Razor-based testing model. So this is slightly different. So in here, you literally write the test code in the component itself. So you use components to test components. So it's quite cool. So you have a fixture, you have a test, you have the component under test, and you kind of create everything, get everything set up, and then in your code block, you can do your sort of checks and assertions and bits like that. So it's up to you. This is a great library. Eagle puts a lot of work into this. It's really good. He's actually sort of done a large contribution to the HTML parser library he uses to do all this. He kind of wrote a whole extra bit for that and stuff. So it's really good. He's had a lot of input and help. I think there's a lot of talking with the Blazor team as well around some of it. But there will be some official stuff that will come out of the box eventually as well. So so the answer is you can test it in multiple ways. It's up to you what you want to do. This is obviously more the unit testing style. You can also do end-to-end testing, and that's just the same as any other UI. You could do things like Selenium or whatever, any other UI testing framework you use for any other SPA, React, Angular, if it's browser-based testing. Where can I get this T-shirt? So this friend of mine, Ed Charbonneau, who's an MVP in America, he works for Progress Telerik. He has an online store. He has a Twitch channel. If you go and watch his Twitch channel, he got a link to his store and you can buy it from there, and you can, enjoy the pleasures I did of paying 3 times the price of the shirt for the import tax. That's great.
That's fantastic. I think I can only see half of it. What is it? Oh, cool.
So it's modeled on the Nintendo Power Glove for anyone who's from the 80s, but yeah, and then it's just got Blazor on the front. So yeah, so you can get that from Ed's store. So if you go to his Twitch channel, you can find the link there. Are there any lazy loading scenarios being thought of binaries, DLLs for Blazor WebAssembly similar to Angular components, keeping the initial size down? Cool. I love this question. So the answer is no. And there will be something put into this, but it's not a priority. And the reason is because you need the entire .NET runtime along with its dependencies to boot the app up. Once you've done that, your app DLL is really, really insignificant, okay? It's like 10K. So then if we take that and break the 3 pages down that we've got into it, into individual DLLs as well, they'll be under a K. And then we've got to lazy load them. It's going to cost more to lazy load them than it will be to load them all at the start. So like I say, the thing here to remember is that, yeah, that's it. That's the, Damien, that's the correct link in the chat for Ed's channel, by the way. You've got to remember here with WebAssembly, because like I say, it's definitely, I get why people ask this question, especially, I mean, obviously I've built Angular apps for a number of years. So lazy loading is a very key and important part of doing that. It just doesn't make sense in this scenario with WebAssembly and how .NET works. I've actually talked to Steve Sanderson about this specifically because I just wanted to make sure that I wasn't telling people the wrong thing. I'm not, which is good. So they are going to look at it eventually and some options, but really you're talking about tiny amounts of data. Okay, if you actually inspect those DLLs in Blazor WebAssembly, go have a look in the browser tools. Have a look at the DLL for your app. Okay, they're absolutely tiny, and breaking them apart to lazy load them just doesn't make sense. It really doesn't. The one scenario me and Steve talked about that does make sense is if you have a particular area of your app that has a very, very expensive dependency. So say, for example, you're doing, let's go nuts here and say you're building an online CAD editor, right? And you have the first few pages of the app, which I know some really easy ones for like listing files out or something, but then you actually load the main CAD editor. Now, that might have a huge dependency that might be a meg or more. That might make sense to lazy load. But generally speaking, in line of business applications, that tends to not be the case, okay? And the IL linker is going to strip a lot of stuff that if you're not using it anyway. So genuinely, the bits that get downloaded tend to be the only bits that are used. So yeah, I saw a bit more was added to that. Hold on. So I was thinking more of the .NET library requirements. Yeah, like I said, I think what I just said might have covered that. If there is a heavy dependency, there's potentially a need for it there, but again, it just doesn't make sense. There's also a very technical issue as well, which is that DLLs can only be loaded into running. Oh God, I hope I get this right. Running .NET apps synchronously. Okay, there's no asynchronous APIs for dynamically loading DLLs in .NET. So that means that in order to lazy load an area in application, bear in mind we still only have single threading and stuff. Well, it won't matter because it's synchronous. Your app is going to stop while that happens. So if you have a large dependency or something like that that's going to involve some churn, you're going to get stuck. So there's another tech that's obviously an issue as well. Whether that can be gotten around, like an asynchronous API could be added, for example, I don't know. That maybe something gets changed in .NET Core or the new .NET 5 wave, 6 wave, whatever, coming forward. So yeah, so there's both technical limitations and there's actually just genuinely how things work. It doesn't make sense. Reasons for not really doing lazy loading as well. So yeah, does that answer things? Do you think WebAssembly with Blazor could replace Angular? I have literally everywhere, but it depends what you're. Again, I want to caveat this. It's very much down to what your use case is, what your team like doing, stuff like that. I don't think there is ever a reason for there to only be one of something. There shouldn't be one front end framework that rules them all. There shouldn't be one browser that rules them all. There shouldn't be one OS that rules them all. You know, we need the diversity and some competition in order to drive, changes. React, Angular, Vue all had an influence on Blazor. If you've done React programming, you'll see that React is actually one of the heaviest influences on Blazor. If you've done React programming, you will notice a lot of similarities in the way Blazor goes about certain things. So yeah, what is the interop story like for third-party JS libraries? When you say interop story, do you mean will it be done for you, or what's it like for you to do it yourself? Oh, what you have to, okay. So what you effectively do is you have to, right, I'll look at that in a second. So yeah, Matt, your question. What you have to do is you write a small piece of JavaScript that wraps the JavaScript that you're calling. Okay, so I'm just thinking if I have, and I'll tell you what, I will do this. I'll show you this on the Blazor docs site because it will just be a bit easier to actually show you some code. There we go. So where's the bit of code that I want to show you? So yeah, so what you would do is you would write a function that sat on the window object, and that would wrap whatever the third-party library is that you were calling. Okay, so that inside of this block is where you would put, I don't know, whatever the initialization logic is for that particular component. If it had other functions that you wanted to call, you could define them all at this top level object. And then you use interop in order to call that from C#. So you inject a JS runtime, and then you call invoke, and then you pass the name of the function that you want to call, and you can even pass down arguments down as well into the JavaScript function. So you can pass like reference to HTML elements, stuff like that. And then you've got another method as well where you can actually get return values back from JavaScript as well. So if you have libraries that do promises, for example, they map one-to-one with async await in C#. So you can literally wrap them, and then you can use C# async await to call them and use that same API. So that's quite cool. But to be honest with you, your question is quite broad because it really does depend on what library you're wrapping and how complex it is. If you want to see real world examples, go have a look at my GitHub. There's loads. Just pick around. There's loads of different examples on there of interop. And I've got a load of blog posts as well, so you can read those. They should explain it. Silverlight S plus the stuff the likes of DevExpress are developing for Blazor, do you think we'll see a common set of libraries farmed out alongside the core Blazor components, data grids, charts, tree views? Do you mean from directly from Microsoft themselves, or? Yeah, from MS. I very much doubt you'll see one anytime soon, specifically because there is already libraries available from Telerik, DevExpress, Syncfusion, and there's already a large chunk of open source libraries as well. With everything else that the Microsoft want to do in terms of adding features to Blazor, because that's effectively being serviced by the third parties at the moment, it's not going to be high on the priority list. I think if you see anything from them, it will probably be a version of the Fabric UI, because that is the Microsoft UI language. But like I say, I doubt you will see it anytime soon. If at all, I don't know if they'd ever get there, to be honest. Would AOT solve the file size problem with Blazor WebAssembly, perhaps with .NET 5? Another one I like. So AOT actually makes files bigger, which is usually quite counterintuitive to what most people think. Yeah, actually significantly can really up the file size. So where AOT is important is speed. So to get that promise that I talked about earlier in the slides of WebAssembly offering near native speeds in the browser, you need to be running native WebAssembly, not doing in-browser interpretation. So we will need AOT in order to get the full performance benefits. But like I say, the trade-off there is a larger file size. So what is probably going to happen is that you will be able to specifically choose parts of your app to get compiled ahead of time. So that will be, you might be able to go like, this particular page component will get compiled, or this particular component within that page will get compiled ahead of time. So you can really focus AOT to where you need high performance, and everywhere else, most applications don't need that high performance everywhere else. So so that will be kind of probably how it will work. Dan Ross mentioned this a few times, that's kind of what they're thinking of how they're doing it. They've already got AOT working in Mono, so it's just, you know, it's a case of choosing how to integrate it properly. Cool. I'm going to jump back to the slides now, and we'll get through the rest of this. So a couple of questions I usually get next about Blazor Server is, and I'm surprised I didn't get any here, was can I scale and what's the performance like? Because that's usually a big thing when people see all this sort of chitty chattiness back and forth. Well, the Blazor team did tests on this, and these are results. So on a standard D1 V2 instance, which is one virtual CPU and 3.5 gig of memory, it supported over 5,000 concurrent connections. Now, I want to be clear here, these are not just connections, these are active connections, okay? So the Blazor team came out with a whole test scenario where they actually have active interaction on the site that they were using, okay? They pushed this to a D3 V2 instance, which is 4 virtual CPUs and 14 gig of memory, and that supported over 20,000 concurrent users. Now, I don't know about anyone else. I've never had to build an app that needs to support 20,000 concurrent users. So I'm fairly confident that Blazor Server will scale for me. That did not use the Azure SignalR service. Okay, so I didn't use that to help with the multiplexing and bits. So that will give you even more scale and stuff. So yeah, it scales pretty well, and it does some pretty decent things. The interesting thing from this is it's actually memory that's the key. So it will scale infinitely in relation to memory. So the more memory you put in there, the more concurrent users you can support. Obviously, until you exhaust WebSocket connections, admittedly. So that's quite good to know. The profile of this will obviously change depending on your app. So 20,000 concurrent users for an app that's low memory. If you bump that to a high memory app, that might only support 5,000 concurrent users. Okay, so it all does depend what your app is doing, but however you cut it, that deals with things pretty well. In terms of summarizing this, so you know, Blazor Server is production ready. It's released with .NET Core. We've had it for a while now. We've got a small payload when we start the app up, which is like 100K, 150K. That means we get a fast load time because everything's pre-rendered as well. We just get HTML, bang, and it's there. We're accessing the full runtime now because we run on the server. We're running .NET Core, full runtime. So that's great. We can do all the fun stuff, play around with files, manipulate registries, all that good fun. And most importantly, as well, for a lot of people, we get code security, okay? So if you have IP that you need to protect, you don't want those DLLs going down to the client to be decompiled, then you can run Blazor Server. It all stays on the server, and you don't have to worry about exposing them. However, the trade-offs, of course, is that we do have a heavy load on the server now. We are running effectively a mainframe style sort of architecture, really. All that main compute is happening on the server now, and the clients are just doing sort of small, lightweight updates and sending these events back and forth. It doesn't work offline, okay? So the moment you lose your browser connection to the internet, it sort of, like I say, covers with this translucent overlay, and it just stops working, okay, until the server connection comes back. So this means that latency and this other one requires fast and stable internet connection are really important. If you have a high latency, the app will become sluggish. Okay, so again, as part of that performance testing, the team noted that 200 milliseconds is like the top end. If you get above 200 millisecond latency, then you're going to start noticing some lag on the UI. What this translates to in sort of more realistic term is effectively it means your server and your client need to be on the same continent. Okay, above that, it can be a bit iffy. And like I say, fast and stable internet connection matters. So that's a bit about Blazor's server, and we've kind of covered quite a few questions there, which is quite cool. So we're just going to finish up by talking about the future of Blazor, okay? And this is the sort of harking back to my why is it so exciting part. There's two other hosting models I've not talked about, desktop and mobile, okay? And these are experimental. So the desktop experiment has actually been around for a very, very long time, okay? It's done as part of a hackathon that the Blazor team did well over a year ago, and they showed Blazor working inside of Electron, okay? Since then, Steve's done another little crazy invention called Web Window, which you may have heard of, which basically takes all of the bad stuff of Electron and throws it out the window. Things like the huge memory consumption and the massive download size, because it strips out Node, it strips out Chromium, which are used to render it, and it replaces it with .NET Core, and it delegates the actual UI rendering to whatever the native web renderer is on the OS. So like in macOS, it's like WebKit, something like that. Which means that the app size shrinks quite a lot. Okay, so he's not like 60 meg off of like an app, stuff like that. So it's a huge sort of saving, sort of 40-50% maybe, depending on the app. And also the memory usage dropped quite considerably as well. And he's done that with Blazor as well. So he's got a version of this that kind of runs any kind of Electron style app, but it's not tied to Blazor. He's just done a version with Blazor in it. So that's kind of the desktop side of experimenting. That uses the same style of components that we saw earlier. So web-based components. So we write HTML and the code block. This is the same component we've been referring to all the way through this talk, that count component. So any of those web components just run on the desktop experiments. Okay, so if you've used those in other places, you can just use them here. It's great. But this one's the fun one. Okay, Blazor Mobile, or to give it its full title, it's Mobile Blazor Bindings, which is really catchy. It's a great name. And this one is very experimental. There's only been 2 previews of this. I've actually just finished doing a blog series on this. I've been blogging I've just done 4 blog posts about this, playing around with it. It's really, really cool. One of the reasons I haven't got into mobile development is because I don't like XAML. I really hate it. And it's always kept me away from Xamarin. But in Mobile Blazor Bindings, that goes away. The idea is that we take that programming model that we talked about right at the start, that top half of those 2 bits of Blazor, and we use that to build native mobile UI. So that component we've been looking at, that counter component we've been looking at, this is what it looks like in Mobile Blazor Bindings. So you'll see it looks very, very familiar. Okay, we've got that markup at the top, we've got the code logic at the bottom. But you'll see that now we're using native mobile controls. Okay, so we have a stack layout, we have a label, a button. This is obviously a mobile label, a mobile button. These are not HTML versions. But you can see things like the Razor syntax is the same. So we've got some Razor expression there to print out the current count. We've got the on-click handler that calls the increment count method. And you can see everything in the code block is completely unchanged. Okay. So it's really easy to move from being a developer that knows Blazor on the web and be able to quite quickly build some fully functioning stuff in mobile apps. I built a little budget tracking app in this blog series. It was really easy to do. I was stunned at how easy it was. And you can all you've got to do is basically learn, instead of a div, I use a stack layout. Instead of using a p tag, I'm using a label. You know, it's pretty easy to get your head around. But outside of that, the programming model's really similar, and the goal is to make this even closer to the web programming model, I guess, as it goes forward. But the key thing to note here, and this is the bit I really like to say, I want to reiterate this again, is that Blazor is not trying to hit round pegs into square holes here. It's not trying to take web UI and somehow manipulate it to be a mobile UI or anything. This is rendering the exact same stuff that a Xamarin app would do. Okay, so on iOS, this is going to render native iOS code. If it's on Android, it's going to run and render native Android code. Okay, it's not doing any funky transpilation or anything like that to manipulate it and stuff. And that, I think, is why I really like it, because it's not trying to, like I say, it's not trying to sort of be this one sort of silver bullet, sort of big umbrella over everything, write things one way and one way only, and they'll work everywhere. You are going to have to change your components slightly. You can't just reuse web components in Blazor Mobile. But if you know that programming model, if you understand that syntax, then you're going to be able to pick up really, really quickly and be able to create native UI that works really, really well. And that's a really key point, and that's why I really like that. And that's why I think it's really interesting to see what's going to happen with Blazor going forward. And that's really what I'm going to leave you with, is that .NET is your platform for building anything we can build on desktop, web, mobile, cloud, gaming, IoT, whatever. And the question I have is that what Blazor is going to be for UI? Is that going to be your UI framework for building anything, anywhere? So I'll leave you to ponder that one at the end. Here's some resources that might be worth checking out if you're getting into Blazor. There's blazor.net, which is the official site. There's a great repo on GitHub, Awesome Blazor by Adrian Torres. He does so much hard work on that repo. It's got so much good stuff in it. It's got demo apps, it's got blog posts, it's got articles, it's got experiments, white papers, it's got every talk that's ever been done on Blazor. It's brilliant. I don't know how he finds the time, to be honest. I'm a maintainer on that. I try to help him when I can, but there's always stuff going on. He's done a great job. So that's got so many good resources on it. There's a Blazor Gitter channel that's always really active. There's a lot of people in there talking and chatting, know a lot about Blazor. I've seen that channel grow from single figures to now 4 figures. And there's people chatting in there every day. So if you need any help and you want instant sort of feedback, there's people in there who can help you. There's a site called Blazor University, which is done by a guy called Peter Morris in the community. And that's a great site. Peter's put a lot of hard work into that. It's sort of a reference style site for Blazor. And it's got loads of great examples of things. So it's definitely worth checking out. And obviously you've got my blog at the bottom. So hopefully there's some useful stuff on there for you as well. So that's pretty much everything. So I know we've gone through some questions, but if there are any more questions, then feel free to fire them at me. I don't know if we want to come off mute and do it. I don't know if that's easier.
Yeah, that's brilliant, Chris. Yeah, so first off, let me just switch to gallery view. Can we all get a silent round of applause? Because Zoom doesn't do, actual audio applause. So we'll mime it. That was brilliant. Yeah, I'm going to unmute everybody for some questions. If we can limit it to 1 question per person just for now, so we can get the draw done, and then we can have a chat after. But yeah, let me just unmute everybody. I think
I'll stop sharing my screen as well, actually.
Oh yeah. I think when we unmute, it will remember your settings. So if you previously had it unmuted, it's going to come back on now. So be aware. Cool. Yeah. So any questions? Go for it. I'll start then. So with the Xamarin Dev, how did you find the kind of feedback loop on that? Was it slow? Did they have the hot reload preview thing ready yet, or?
No, it hasn't got hot reload in it. It's probably it was the most painful point of it, to be honest, because you did have to make a change, rebuild, and then go back over, refresh the emulator, or let the emulator reload. So yeah, it was a bit painful from that point of view. But it's only had 2 previews, so there's a lot of work to go into it still. And yeah, they're kind of actively looking for feedback on that as well at the moment. So so yeah, it'll just get better over time, really. But this is to be fair, I've been living the preview / experimental life since Blazor came out. So I've become a little bit numb to preview versions and a lot of manual steps, which is possibly a bit bad sometimes. I'm like, oh yeah, you've only got to rebuild it and then refresh the browser and then do this, and it just works. But yeah, but a lot of these niceties are coming along now in other bits of Blazor as well. So that's cool.
Someone must have a question.
Everyone's got shy now.
It was a good set of questions halfway through. Samuel asked, are you going to do an advanced Blazor course?
Am I going to do an advanced Blazor course? It depends what you mean by advanced. Possibly. It all depends. The only real advanced stuff I would say with Blazor at the moment tends to be around some of the authentication stuff and the advanced stuff around really sort of creating really sort of advanced components. So UI components, things like the type of head I have, for example, that has had many, many days of development work put into it to get it to do certain things and stuff. But yeah, I think it's definitely something I'll look at doing and put some talks together around it. I'm going to start. I've got some talks actually that deep dive into very sort of tight areas of Blazor. So I've been working on a talk that deep dives into forms and validation in Blazor. I've got one that I did one on routing actually for the .NET Conf Focus on Blazor event that's up on the Channel 9 site. That was about a half an hour talk, but I can easily stretch that into an hour. So I'm going to sort of redo that one to sort of go into some sort of real nitty gritty of the routing system and how pages are loaded and diffing and stuff like that. So I'll be adding those bits in. So yeah, they'll probably be coming. Just at the moment, obviously the majority of people are getting into Blazor, and kind of that's where the volume is in terms of where people need to learn the knowledge. So I'm trying to get the basics out there, and then we'll move on sort of as soon as we can, really. But yeah, I will throw a few more advanced stuff out where I can.
Cool. One from Alex B. Are there any plans to have a similar alternative to the HTML helper class?
I don't know. I was just trying. I haven't written any stuff in MVC and Razor for not in Razor Pages or MVC for a while. I'm trying to think what was on HTML helper. Anybody, please just throw some methods.
I can't remember. It's that long ago. I remember doing it.
I know.
Helper dot.
Yeah, I remember doing HTML helper.
Label 4 and stuff like that.
Label 4, yes.
Yeah. Oh, okay. Yes, of course. Yeah. So things like Label 4, there's a Blazor component equivalence. So the way, it's all coming back to me now. So yeah, so things like the HTML helper class itself don't kind of make sense in Blazor because it's a component-based UI, not a what's the word, imperative based or something. So you tend to write things, you write UI based around components, not around just calling some arbitrary method on a class to spit out some HTML. So there are components like there's so I don't think this is an HTML helper method, but there's like validator for, wasn't there, and stuff like that. But there's a validate component that has a for parameter that you pass in the field you want to show validation messages for. So there's kind of equivalence in Blazor where it makes sense, and then the other stuff that's not in there probably just doesn't make sense to be in Blazor apps.
Cool. Okay, let's hold it there then and do the draw, and then when anyone want to ask any more questions after, we can do that.